In this session, we are going to discuss a new topic and very important topic about the management of Kubernetes application and deployment of Kubernetes application by using Helm. So Helm is basically a tool that you can use to for the deployment of applications on the Kubernetes cluster. So basically, it's the package manager for Kubernetes. Helm is the best way to find, share, and use software built for Kubernetes. So whatever manifest you have written, manually you can deploy, but Helm can give you the great leverages and benefits and version controlling of your application uh, to to deploy on the cluster. So let me show you first of all some basic concept. If you open this helm.sh, this is the basic URL to understand the Helm uh, tool. So here you can see what is Helm. Helm helps you manage Kubernetes application. Helm chart can help you redefine, install, and upgrade even the most complex Kubernetes application. Charts are easy to create, vary and share and publish. So start using Helm and stop the copy paste. Helm is guaranteed you project by the CNSCF and is maintained by the Helm community. So let me give you a quick overview why we need Helm and how it will work. So my Kubernetes cluster is up and running, and only one worker node is up and master node is up. So first of all, or so far, what we did, we create the manifest. To create an application, we need pod, and you will not run a pod as simply just like a pod. You will run the pod in the form of deployment. You will associate some service. You will create some ingress resource. You will create some horizontal pod auto scaling for the application. You will create some database and a lot of other resources maybe you need, but these are the bare minimum resources you need for a very simple application too. So what you can do, you can put your all the manifest you created in some directory, and then you can apply. Just like, let me give you an example. Just like I can say I create a directory, my app1, app1 I create a directory. Okay. And in this directory, I create a deployment. So for kubectl, create deploy -image is equal to, for example, nginx, whatever image you want to, in the, for example, dev namespace you want to deploy. Kubectl create create deployment name is missing. Okay. Deploy, I can also write, for example, sample app one. This is the manifest. I will throw this manifest in some file, sample app1.yml. So you can see this file is created. Similarly, you can create you can expose this application. How you will expose kubectl, expose deployment. Name of the deployment is sample app1, and you want to do this in the dev namespace, and type is by default cluster IP hyphen port you want to expose to 80, and you will do the dry run -yml. Let me just check. This deployment is not available, But when you will do this deployment, then you can do this. But you can create some a resource manifest like this. So for example, you put all your resources under this directory, sample app.yaml. You can put your manifest of your surveys, ingress resource, everything. Now, what you can do, kubectl apply -f. Straightforward, you can give the name of this directory. And whatever is available in this directory will automatically be applied. And if you look now, kubectl get pod-n in dev namespace, it is up and running. This is a way to manage your application in general life. You can create multiple directory and you can put all the manifest in one directory and everything will be working fine. But what about if you want to just change the image in this app1 directory, in this sample manifest, this image to some different image. You want to put some resource. And if you set up some resource limit and request CPU memory, and you want to change those values for different application, you want to add one more container in this application. You want to change the label, the name of the label, or you want to change the name of this application, or you want to change the replicas. So every time you need to create a copy of this manifest. So that's why they wrote in on their website, stop, stop the copy and paste. So this is a problem I just showed you quickly. If you want to change anything, you need to edit this file manually, and or you need to create multiple directories and put different application manifest in different directories. That is a way to manage your application. But Helm, how Helm can help us? Helm will basically provide us the way to deploy the application. I mean, Helm will help us with the variables. Just like this is the replicas and its value is 1. So you can put some variable here, and that variable value is manageable by the Helm chart. And in that variable, you can define the name of the value of the replica, and uh, your Helm chart will provide you a different application. Similarly, you can put here the name of the image as a variable, whatever changes you want to do, resources, whatever you want to change. So this will help you to use the same manifest for the multiple application. What you need, just you need to put the variable. So let me show you how Helm is doing this. So first of all, you need the Helm binary. So right now I am on my master node, but you can install Helm on your Windows, Mac, and Linux anywhere. So far I am using this master nodes to communicate with my API server. That's why I will install Helm here. Helm will, at the end of the day, will be using the kubectl and will be using the same config file uh, to get the authentication to the Kubernetes cluster. So if I go to the documentation, this is the home page. Here is the docs, and in the docs you can see the quick start guide, and the prereqs, the install Helm, and here is the installation method. So this is the binary. You can directly download the binary from its website, or to install on the Linux, you can pull down this binary, and you can give the permission and put this binary in some run this script, it will install. Similarly, you can install on Windows, on whatever platform you are using, you can use. On Debian, you can use like this. So here in the yum, this is a method of straightforward. You can use the yum DNF install Helm in the Red Hat or RPM based distributions. So right now I will use this method. This method will be applicable on any distribution. So what it will do, it will pull down this binary. And if I show you here, this script is pulled down, but I need to do chmod. I just need to give the executable rights to this script, and I need to just run this script. So this script will automatically go to internet, will pull down the latest binary, will extract it, will put it under your binary directory, bin directory. And now Helm has been a part of my operating system. So if I type Helm hyphen variant, I believe this is the command to validate the variant. Yes, -v I can use. Helm help. So to look into the variant, I just need to type straightforward variant. So this is the Helm variant v3.153. This is the latest variant. So now Helm is installed on my machine. If you are using your kubectl from your Windows machine, you can install from your Windows. If I go to my Windows CMD, I can show you. So far, my kubeconfig variable is not set for my Windows. So that's why I'm not using the kubectl and Helm from my Windows. But Helm is installable on my Windows machine too. So I already installed on my Windows machine. So far I'm using from Linux, and Helm is ready. Now, I have a documentation uh, where I put everything, the bare minimum information you need to know about how to use the Helm. If you go to this documentation, you can get a lot of ideas, but as a new user to Helm, you should this document this document is shared in the Git repo. You can pull it down, and but if you want to go to the detailed documentation, you can use the using Helm. And in the using Helm, just read all these concepts. You will get the idea how this whole stuff is working. Okay, so let me go back to my machine, and here I have Helm here. So in this documentation, I also mentioned the installation uh, method, and how you can check the variant name number. So if you just type the variant, it will show you the long format. But if you want to see the short, I think in this variant, uh, yeah, I think HLM. Yeah, this is the short. This command will give you the quick variant number. Helm variant short. So here, uh, first of all, how Helm is helping us to make our life easy. So uh, there are two concepts you need to understand. There is a Helm repository and there is a Helm chart. We have to work with the Helm chart. Actually, Helm charts are the combination of different manifest. Whatever application you want to install with the Helm, it contains the manifest, and there is a variable uh, file that contain all the variable values that will help you to dynamically change the values inside the manifest. Uh, so Helm, so chart is the collection of manifest and values, simple you can say. And the concept of repository is the collection of different charts. So online on the Git or different locations on online, I will show you there are different repositories and different repositories for different projects. So when you will pull down a repository, that repository can contain a lot of charts inside it. So The concept of repository is the collection of charts, and a chart mean a specific application related manifest and its variable values. So let me first of all show you how you can create your own chart. So Helm, if I just take a look, what was the command? Helm create. I am going to create my own chart. Chart mean the application, complete manifest and variables. So create, for example, I can say my app one chart. Okay. So what happened here, a directory is created here with the name app1 chart. If I go under this app1 chart, so here you can see the complete directory structure is created. Actually, the Helm create command help us to create the whole directory structure. But you can also create this whole structure manually too. But so far, the Helm command is giving you the leverage to create this everything automatically. So it's better to use the Helm create method. So now I will show you what has been created. There is a file values.yml. It contains all the variable values, whatever you can change dynamically for different to change directly in the manifest. The templates directory contains the manifest, and chart.yml is the variant number about this information about this chart, the variant number of this chart, and the name of this chart API variant is mentioned here. And what else? So let me show you this template directory. Inside this template directory, you can see sample deployment YML is created. Horizontal pod autoscaler manifest is created. Ingress created. Notes about this whole files are created. Manifest service account is created. Service YML is created. So these are all the manifest you minimal uh, uh, manifest you need to deploy an application. You can put your more manifest here. So let me show you this deployment, how what is written in this deployment. This is the same deployment, but here you can see the name of the deployment is declared as a variable. This variable is coming from this this is the name of the variable. This is defined inside our variable file. So where is that variable file? This one, the values.yml. Okay, so let me go back again to the templates, open this deployment, and here you can see the label is also coming from the variable and this it also contains the conditional statement. If some variable value is enabled, then do this. If this is not enabled, then do this. So then the replicas, number of replicas are coming from the values variable. This is so you just you can see in this whole file everything. This is the same manifest file, but the values are coming from the different variables. So dot values node selector, dot values volume, okay, dot values volume mount. Okay, you are so just like dot values service dot port. So these all values are coming from the values.yml file. If I show you this values.yml file, you can see this is a variable replica count. Its value is 1. The image repository nginx. So how this variable will work? Values.image.repository. Similarly, values.image.pull policy. With this way, the variable will be called inside the manifest. Say image pool secret is a variable, its value is nothing. I mean, you have not defined here. So here we can provide the name of the variables. So just like, let me show you here they use the image name nginx. Okay. And image pool policy is, I mean, if image is not available, then it will be downloaded. This is a default policy. Similarly, if we go down, the replicas, number of replicas you can change here. Okay, that will automatically be reflected in the deployment. Similarly, security context, this we discussed in our security Kubernetes security deep dive videos. You can see those videos. And similarly, pod label we can define, service, whatever service will create the cluster IP or node port or load balancer, or what type of service you want to create. So by default, it's creating a cluster IP, exposing the port 80. You can change this. Then ingress, by default, ingress enable is false. So you can also set the ingress for this application. Uh, you can see the video we did on the ingress controller in detail. Uh, and the TLS, everything you need to set up an ingress resource. Okay, and then the resource limit, by default, these values are commented. So if you want to enable these variables, you will enable those and you will remove this curly bracket. Okay, so by default, these values are available. So let me, and auto scaling for horizontal pod autoscaler, minimum values 1, maximum values is going to 100. That is too much. But let me just apply the same value. And the target CPU, when the CPU value will reach to 80%, it will create the new uh, pod. But this auto scaling is false. You can set it to true, then this auto scaling will work. And or to enable the auto scaling, you must need the metric server. So if metric server is not deployed, then it will not work. Similarly, you can define the volume and volume mount and node selector. Okay, which node you want to use to deploy this application, toleration, affinity, anti-affinity. We cover all these topics in very detail. So these are all the related variable values uh, defined in this variable file. So these variables are going in this template and affecting all these manifests. Let me show you this now. Horizontal pod autoscaler. So here you can see this is a name coming, and this is the name of the chart. With the name of the chart it will be. And here uh, these were values dot auto scaling dot minimum replicas, maximum replicas. Okay, so this is the whole HPA we created, horizontal pod autoscaler resource. And similarly, if I show you the ingress control, ingress resource. So here you can see this is a condition they set here. This is the complete language of Helm. So it will automatically create the new manifest, but I showed you in the value that value.ingress was disabled. If that is enabled, then it will create all the complete manifest of the ingress resource followed by the variables. But if that is disabled, then it will not create anything about the ingress resource. So let me now apply this chart we created. The chart name is app1 chart. So how can I apply? So to apply this chart, I just need to apply like this. Helm, apply Helm install app1 chart, and in which namespace. For example, I want to apply in, for example, UAT namespace. So namespace I can define separately. Uh, just a minute, I think I did a mistake. Yes, I need to provide the name of the chart. For example, I can say app1, and then this is a path. Yes, it is deployed. So this is a way to deploy if you have a chart, complete chart directory structure. Then you will deploy like Helm install name of the chart. That can be any meaningful name, and then the directory that contain the chart whole directory structure, and then the namespace where you want to deploy. Okay, so now this chart gave you some useful information that what is the name of this chart, when this was last deploy, maybe previously you already deployed this and you again deployed this, so then it will show you last deployment date, in which namespace, what is the status, version number, first time it is deployed. Note, get the application URL by running these commands. If you run these commands, this whole command, so this is doing export an environment variable, and this whole command will give the pod name that are created under the deployment, and the container port, if you want to know, you can get by this whole command, and then you can browse your application by using this port. Okay. So this whole information you can see, then it is using a port forward. It is suggesting you that you can access your application since you have exposed your application with the cluster IP. So to access your application just for the testing, you can do the port forwarding. We did a detailed video on port forwarding. So all these variables are placed here, and it will give you a final output. So this is the meaningful information given by this chart. You can run these commands, you can get the idea how this is working. So let me just run this. And if I do an echo $, pod name, so this is a pod running by the deployment. So if I see kubectl get deploy -nuat namespace, you can see this is the name of the deployment. So the name of the deployment is the name I used and then the name of the chart. So actually I use app1 twice. That's why it is coming here like this. And 1 out of 1 pod is ready. And if I look into what else it's created, SVC. So you can see the cluster IP services are automatically created. What else created? Ingress resource. No ingress resource is created because I disabled that. And what else I can see? -all. So cluster IP, deployment, service, only these resources are created. So now, if I run this variable, this command, it will give me the value of the port number. So now both variables are saved. Now I just need to run this command. And now if I, from my localhost machine, if I hit use this URL, this example is given here, then I can reach to my application. Okay, so I am just doing a Control C, and you can see how quickly I deploy an application. So if I just make a modification to the same manifest, and to see how how many charts are deployed right now. So Helm uh, list command will show you how many charts are there. So far, I have not defined any namespace name. So charts are deployed in the namespaces. So I deployed in the UAT namespace. So in the UAT namespace, you can see the chart name is app1. In this namespace, it's first version is deployed. At this time, it was updated, status successfully deployed, and chart version is given. And one more thing I want to show you. kubectl get pod -n UAT. This is the pod running. If I just do a describe pod -n UAT, so here you can see the Nginx and its tag is 1.160. So from where it fetched this tag? Since if I go in my chart and here in the values, the image name does not contain any tag. So from where it get the tag, the answer is it's getting the tag from this chart.yaml. So this chart version number is 1.60. So this will appended as the tag of your application image. So you can change this too if you want to change the tag of your image. And so now let me just change this value. So in this value, for example, I want to change replicas to 3. Okay. And I am also interested for the ingress resource. I want to set it to true. Okay. The class name, ingress class name I need to define. So let me just check kubectl get ingress class. Ingress class name is Nginx. If you are confused with the what is ingress class, with a detailed video on ingress controller, so you can consult look that video. So here I have to define a class name, okay, and annotation. You can use this annotation, and the URL, the domain name that you want to uh, access, for example, example.com. So externally, this URL will be able to access this application. This is a path. TLS is not implemented. Just I change one thing. Let me just again deploy what I change. I change the replicas to 3 and I enable the ingress. So what I will do, I will kubectl Helm. I will install home directory. Now, yes, here the name is already there. So Helm, I think update uh, Helm hyphen help. Just let me check from the documentation. Helm upgrade. I think the syntax is upgrade. Yes. So what happened if you change the value in your chart and you want to apply those values? So now you can see the revision variant is 2. Okay, it's deployed at this time, last deployment time, same thing, but this time when I will do kubectl get deploy hyphen and UAT, you can see now pods, 3 pods are running. 3 pods are up and running. And if I look into kubectl get ingress resource in the UAT namespace, you can see the ingress resource is also created with this domain name. I don't need to create my own ingress resource. So it's automatically created. Nginx ingress class is ready. And if I describe, just to look into this ingress resource, either this is healthy or not. So you can see it is pointing to this service and all 3 pods are connected with this domain now. Okay, so I hope you got the idea how chart help us to control the deployment of application, how easy it is. We just need to play with the values. We don't need to go and in the manifest and change the values manually. Similarly, what else we have in this chart? If I go under the template, there is a service already created, service account I just left. If I show you the notes, so notes are basically the same thing from by using this node.txt file when I deployed this chart. So after at the time of deployment, it gave me some useful information that what is deployed, what are the whatever information is given, you can fetch from here. It will be printed by using this notes.txt file. So for example, now if you have a chart already deployed, so Helm list hyphen n in UAT, how many charts are there? There is chart number. Second time it is deployed with some modification, and the app variant you can see 1.160. This variant number is coming from the Helm chart. Helm chart chart.yml. Okay, so now if you want to reproduce the the output that was generated at the time of deployment of chart, so there is a way to status. So you just need Helm status app1 in UAT namespace. So it's same when I deployed the second time, same information was same information came. Okay. So you can also change to the older revision. For example, whatever changes you did in this Helm chart, you have revision 2. But you think that you did some mistake, you want to get back to revision 1, so you can use Helm rollback up 1 to revision number 1. Sorry, in UAT namespace. So rollback is done. And now if I list revision 3 is deployed, because I did them changes, and if I look into the kubectl get ingress in the UAT namespace, you can see the ingress is removed because I roll back to variant 1. Okay, so in variant 1 there was no ingress resource, and similarly kubectl get pod in the UAT, it will be only one pod. So in revision 2 there were 3 pods. So this is the way you can change whatever values you change. You can change, you can reapply with the older variants. So now you don't need to play with the kubectl commands. You can just use the kubectl commands to look into the resources are deployed or not. You can totally coordinate with Helm only to deploy the chart, and your resource is ready and you can access your resource. So kubectl will only be used for the troubleshooting purpose. Okay, now we just look into how we can create our own chart. This was a simple way. If you create a new manifest here under the template, for example, you want to create a front-end deployment, and so you need to declare those variables inside this values.yml. Okay, so this is not a difficult job. If you go to values.yml, so you can declare a variable simply like this. Like a simple variable name is straightforward. But if you want to define multiple variable related to one value, just like image contain 3 variables: image.repository, image.pull policy, image.tag. So with the indentation, you can define the second level of variable. Then that will be called with the dot. So this is a straightforward variable. Okay. So now you got the idea what is a Helm chart. So simply I am repeating, Helm chart is a collection of manifest and their values. So just you can copy paste this directory, and you can change this value for the different project that will be up and running. Now if I go to again this helm.sh, so here is a chart section. So artifacthub.io contain some publicly published projects charts are available. Whatever we did manually, for example, we deployed the ingress controller, we deployed storage class, we did everything manually. I showed you everything manually. You can do this with the Helm chart. Just like I create the let me show you what I did manually. kubectl get namespace. So ingress Nginx ingress controller I deployed manually in this namespace. If I show you all the resources, get all -n. You can see this pods, service, deployment, a lot of other resources, the roles and role binding and cluster roles and service accounts, lot of things we created. We create the custom resources too. So we can deploy, if I do the rollback or do this ingress, ingress, I can deploy by using some Helm chart. So if I type here nginx ingress So these are the multiple charts given by different companies. So here I can pull down this ingress ingress chart, ingress and ingress controller for Kubernetes using Nginx as a reverse proxy and load balancer. Okay. And this is the complete documentation. Okay. Here is the information how you can add, how you can install. If you click on the install, it will give you the straightforward way. You copy this command. So far we create our own chart. Now what we are going to do, we are going to pull down a chart from the internet. And the command is helm repo add. This is the name of the repository. Repo mean repository, add. This is the name of the repository, and pull down from this location. Let me just press enter. And now if I type helm repo list, so how many repositories do I have? I have this repository, name of the repository. You can change this repository name, but this is meaningful. I left as it is. It was pulled down from this URL. Okay. And now if you want to see install chart, to install the chart, they straightforward use this command. So before installation, I will show you how this is working. So actually we have this repository. So where is our chart actually? The question is, this is the repository, but where is our chart? So you can use Helm search repo, this in ingress nginx repo. So when I search this, so I found inside this ingress nginx repo, there is a chart named ingress nginx. So the repo name is same like the chart name. And the chart version is 4.111.1. App version is this, and it will deploy the Nginx ingress controller. Okay, let me show you another chart example. I'm not going to deploy this one. I will show you some example. For example, I want to use a database Postgres. I don't need to struggle with the Postgres. One more thing I want to show you, that in Nginx controller, you can see all these information are given, how to install this chart, how to uninstall this chart, how to upgrade this chart. And the most important thing is all these values. These are all the values that are associated with this chart. And just like I can show you, there are a lot of values. You don't need to change everything, but in deployment of chart, you need to study all these values at least once. Like what image we are going to use as reverse proxy. This image will use. Okay, and what is a tag for the image variant? This will be the tag. Okay, so these are the values coming with this chart. Similarly, there are a lot of values. Mean the service that will be exposed to the cluster. We discussed these concepts in very detail in ingress controller. What are these values in our ingress controller video? So what type of service you want to use? Similarly, how many minimum replicas you need? How many maximum replicas? I believe they are also using HPA. When the load will come on the ingress controller, it will auto scale. Okay, CPU utilization, and so 50% utilization will increase the auto scale. Will do the auto scaling. Similarly, the container port are 80 and 443. Okay, so there are a lot of values. Similarly, there will be a value like replica. Uh, just a minute, just do a search. Replica. Rep- yes, the startup. No, yes, this value is the starting value of this. Your replicas will be replica outcome. This value. I mean, the very first time deployment will use the one replica. And you remember in the ingress controller, we can deploy by either by deployment or by a daemon set. So there will be something deployment. Hello, by deployment. There will be some value. It will take time to show you, but you can, if you scroll right side, each variable value is also explained here. If you cannot understand, if you are not understanding what is the this value, you can read this documentation. So now if I search a different chart, for example, Postgres, uh, PostgreSQL. So this is the PostgreSQL. This is from Bitnami, and this is the complete documentation. This there will be a list of variables. How this is working? This is uh, yeah, how many charts are available under this chart. So Postgres and subcharts are also available in this one. So this actually you need to spend some time before applying any chart to read this complete documentation. This is the global image. These are all the values. Global image, which with image registry they will use to pull down the Postgres image. So let me just, if I go to the install, so you can see this is the chart. I can just add it. It will pull down the whole data in some location on this system where all the whole directory structure of this chart will be downloaded. So now if I list Helm repo list, you can see I have two charts. So now let me do a Helm search. These are two repositories, sorry, not the chart. So I don't know how many charts are available under these repositories. So Helm search Bitnami repo Bitnami, and that is Bitnami repository. How many charts are available? So there are a lot of charts available under this Bitnami. Actually, we type here Postgres. So it means Postgres is also a part of this repository. But there are a lot of other charts are available, just like you want to deploy a Redis, Redmine. A lot of Bitnami is providing a lot of things, Solar, SonarQube. So if you search here the MySQL, you can also deploy. Okay, MariaDB. So here I am just interested in Postgres. With this way, I can get the name of this chart. So this is variant 15.15, and this is another chart that is providing the Postgres high availability, mean multi-node, multi-pod based Postgres deployment that will do the replication. And you know the stateful set replication we discuss in detail stateful set we need to do the database replication. So it will deploy everything. So let me just deploy this chart. But you, if I deploy this chart, for example, like Helm install some name, I can say uh, PGDB is the name of chart. Okay, and from this repo, use this chart, and in this namespace. For example, I'm saying in the dev namespace, deploy it. Or for example, I am creating in a different namespace, like a database namespace, data BASE, database namespace. And so this namespace is not available. When I will press enter, it will give me error. Namespace is not available. So here you can type create namespace hyphen create namespace. So it will automatically create that namespace too. You don't need to create that name, and it will deploy with the default values available uh, in this repository, in this chart. Along same like chart I create manually. So here the name, deploy, database, revision, everything, database version. Please be patient while the chart is being deployed. Postgres can be accessed via port 5432. So you need to read all these informations. It will give you all the information, whatever is created. This environment variable will give you Postgres password. This is very important because Postgres is deployed, but you don't know the password. So if you just run this command, it will save your uh, password in this variable. This is the Postgres user password. And to get the password of the Postgres, run this command. To connect to your database, run you can use this command, Postgres client we can use. Okay, Postgres client is also running as a pod inside, I think inside this deployment. So this is the complete information about this database. So now if I see kubectl get namespace, the database is created. If I look into kubectl get all database, so here you can see a one pod is created as a stateful set. How I know it's a stateful set? This is -0. So only one port is created, and it is still in the pending state. And I believe it is trying to pull down the image. And here are two service created. One is a headless service that does not contain any cluster IP, and one is uh, for the external access, the cluster IP service. And there is a stateful set running, and a lot of other resources may be created. But so far, I'm just interested to see the pod is up and running, is still in the pending. If I look into get describe the pod in the database namespace. So here, pod has onboarded immediate persistent volume. Yeah, the persistent volume I have not provided. So it's mean it will not work. So I must have to modify this chart before the deployment, because uh, database need the persistency, and I have not provided any persistent volume. So Now I need to, if I look again, the Helm repo list. This is the Bitnami, and here I install this one. So here I want to inspect the values. So I can do inspect. um, Values. Yes, these are all the values. This is the complete value file of this chart. And I can save these values somewhere like under the temp. I am using like Postgres.vl values. Let me just open these values. So here you can see the image registry is none, mean it will by default use the Docker registry. Default storage class. So storage class is mandatory. So far, the storage class, I think I have not. I have storage class, but that is not the default one. That's why it gave me the error. And the storage class is mandatory. So by using that storage class, it will automatically provision the volume and will deploy will provision the persistent volume too. Let me just enable my NFS server. And kubectl get storage class. Okay, NFS client, we deployed. And I need to provide a storage class here, or I can define here the default storage class or this storage class, or both. Maybe we can define. The explanation is also given there. So then the Postgres password, it will generate a random Postgres password. You can fetch later on, but you can define your own password here. Just like I want to set some password like 1234 ABCD, just a simple password I set here. Some username, that user password, some database I want to create. Okay, all these, it's a service port. By default, it's 5432 if you want to change it. And so I believe this was the only cluster domain. So my default cluster domain is cluster.local. If this is something different, I must have to define here. So I believe this was the only registry, and the Postgres image will be used, this image, this tag. So there are a lot of values. So the thing is, basic concept is deployment by using the Helm chart is easy, but you need to spend time to understand what the chart contains, all the values. These Postgres values, password, username, password. So this is again coming now. We need to look into what was these values and those values. So we need to look into the complete documentation of that page I showed you. Okay, LDAP. We can make the connectivity with the LDAP. If the LDAP server is available, then complete information about the LDAP. So I am going to, now I save these values. Now I will show you how I can, first of all, Helm list hyphen n database namespace. Okay, it is deployed, but it is not successfully deployed. kubectl get pod hyphen n database, it is still pending. So I will Helm uninstall, or I think we can also use a remove, uh, uninstall pgdb from this namespace. So it will delete all the resources, whatever manifest, everything ran is removed. Now I will install again. Okay, last time I use I'll install pg this one database name. Here I will type values from temp postgres values. This time I'm not defining the create namespace because namespace is already created. So help install pgdb. Okay, so this time I don't want to use the default values. I am providing my own values. Now you can see the same information is given here. Let me check. The password of the database is created according to my value or still. Yes, you can see I change in the chart and then password is set, whatever I set. So now I hope things are good. So kubectl get pod hyphen n database spending. Let me check, is this creating any PVC in this namespace? Yeah, it is trying to create the persistent volume, but it's pending. Maybe my NFS is still down. My NFS server is up. And let me check one more thing. kubectl get namespace. kubectl get pod hyphen cube system. Remember, we create the storage class. Our storage class is not running. Storage class is not deployed properly. I remember in some session I create the storage class, but here I cannot see any namespace related to storage class, or I thought I created in the cube system. So that's why our persistent volume claim is pending, because our storage class is not functioning properly. So in the next session, what I will do, I will first of all deploy the storage class by using Helm chart. And for the storage class, let me show you what Helm chart will have to use. So it will be something NFS external subdirectory provisioner. Yes. So this chart we need to deploy. And then we will use these this storage class, and then we will deploy some Postgres. Whatever issue we are getting, we will fix it. So right now it will remain in pending because our ingress storage class is not working. So I hope you got the idea. In the next session, we will do some practical implementation of the Helm charts.